Your next homework assignment is out there. It's July the 15th, 2 weeks from tonight. Just click on homework and a Word document will open. Let's read through it quickly. See if there are any questions that you may have. The trucking company has available 3 types of trucks. Type 1, Type 2, and Type 3. It is contracted to carry 3 kinds of equipment. L, M, and N. The following table shows how many units of each type of equipment that each type of truck can carry. So, for example, truck of Type 2 can carry 1 unit of L. Going down the Type 2 truck can carry 1 unit of L, 2 units of M, and 1 unit of N. Okay. And for those of you who work for UPS or FedEx, these are a piece of cake. Suppose the order specifies 20 units of L, 26 units of M, and 15 units of N. How many trucks of each type should be used to ensure that all trucks are full? You don't want to have any empty trucks rolling around out on the road. Okay. So if you order a bunch of truck 1s, then you got to make sure that you send them out the door all full. You don't want any partially loaded trucks at the end of the day. Question 2 is just find the inverse of that matrix of trigonometric functions. Number 3, find the determinant of that 4 by 4. Number 4, for what values of x is the matrix invertible? And so there are 3 cells in there, and presumably x takes the same value in all 3 places. So your job is to find the value from x that makes that matrix invertible. And then once you've found the value for x, it tells you to do it. Find a 3 by 3 matrix A. I love this one. This kind of turns the eigenvalue problem around. Usually, we give students a matrix and tell them to find the eigenvalues and the eigenvectors. This time I give you the eigenvalues and the eigenvectors and tell you to find the matrix that produced them. I love this one. Assume a continuous random variable u whose probability density function is given as f of u is equal to 1 over 5u, and the domain of f is the numbers greater than or equal to 1. Evaluate the function at 3 and at 5. That is, find the density at 3 and at 5. Graph the PDF, the density function, from u is equal to 1 to u is equal to 10. So you got to get out some, do your graphing software or whatever. Find the cumulative probability function, big F of u. That is the probability that the random variable u takes the value big U. You got to find that CDF or what you call it there. Cumulative probability function. Evaluate the cumulative probability function at 3 and at 5. Those 2 numbers, of course, are different from the other ones. And then graph big F over the domain u support u equal 1 to u equal 10. And then, moving right along, let the variable x represent scores on an aptitude test. The following sample of test scores is given. Graph the data in a histogram in class intervals of 0 to 9.99, 10 to 19.99, and then all the way up to 90 through 99.99. So you understand what that means. What you're doing is you're dividing up the support for this data into increments of, or intervals or bins, 10 units wide, and then you're allocating the observations on the random variable, that table of numbers, across those 10 bins, and then charting the frequency. So it's just a square problem. I think certainly MathCAD can do histograms, Mathematica and Maple can both do histograms, Excel can even do histograms, although it's a challenge to get Excel to do it. It likes to see the data in very specific ways. Really funny. But you guys will figure out a way to do it. Compute the sample mean from the group data. So each interval has a midpoint, 5, 15, 25, 35, so on and so forth, through 95. So you take the midpoint as representative of all the data that's in that cell. And compute the early group data, calculate the sample mean. Compute the sample mean for the raw data. That means all the original observations. I would be very surprised if the numbers turned out to be the same. Compute the sample standard deviation for the raw data. Construct a 95% confidence interval for the population mean. You also know how to do that. No problem. At the 10% level, test the hypothesis that the population mean is 60 against the alternative, but it is not 60. So it's a two-tail test. At the 10% level, test the hypothesis of the population variance is 4,200 against the alternative that it is not. The savings function for the economy. This is the aggregate savings function. There was a day when people talked about things like the aggregate savings function. I suppose people in St. Louis Fed still do. So the savings function for the economy is given as S sub t is equal to A plus B times ST minus 1 plus C times YT plus B times IT plus ET. Where big S is the savings in year T. So S sub t minus 1 was the savings done last year, a year ago. YT is income this year. And little I is interest rate in the current period. And U is the disturbance factor, because we don't observe that. Estimate by least squares the parameters of the savings function. So the parameters are A, B, C, and D. What percent of total variation in savings is explained by the model? Which coefficients are statistically different from 0? Whatever software program you're using to do this will tell you those things right off the bat. All you need to try to do is read the numbers out of the table. And what's the short-run marginal propensity to save out of income? And then because I have a bunch of people in here from the MSFE department, and you all learned all about stochastic calculus, we know everything all about a steady state. Well, sometimes even with discrete time periods, we think about the steady state. So what's the marginal propensity to save out of income in a steady state? Okay. Any particular questions concerning Laura?
You know how to steady state stuff into non-financial?
Oh yeah, you're an economist. That's the assertion. Right? And I have to certify you all as having studied economics and econometrics in particular.
What's a steady state?
What's a steady state? Anybody want to answer Laura's question? By the way, if you were a student at the University of Chicago, your classmates would never answer that question for you. Maybe I told you this, but when I was at the University of Illinois as a student, there was a guy in the program who had started at the University of Chicago, and he stayed for a semester. He hated it. He said the faculty were awful, and the students were even worse. They set up study groups, and because he had been an undergrad at the University of Illinois, and most of the others were from Stanford and Caltech and MIT and Harvard and Yale and Princeton and so on, they wouldn't include him in their study groups because he wasn't blue ribbon enough for them. His pedigree wasn't right. And then they had a reading assignment for the classes. We went to the library and somebody cut the articles out of the journals. So the other students couldn't read them. He left after the semester so he didn't need to live like that.
I think they do that at Harvard too. Harvard Law Review developed kind of.
And but another classmate of mine who's also at the University of Illinois, he left Illinois to go to Chicago. He heard the stories about how competitive it was. He said, "That's for me. That's where I want to go." So he went to Chicago and got his PhD there.